So I'm going to do several problems for heat capacity, and I'm probably going to break this up into two videos. So this is going to be part one. So let me paste the problem, make it bigger for you, and put it in black. So it says a 15.75 gram piece of iron absorbs 1,086.75 joules of heat energy, and its temperature changes from 25 degrees Celsius to 175 degrees Celsius. Calculate the specific heat capacity of the iron. So first things first, I always want to write my formula. Q equals M times C times delta T. Okay, and just remind you that Q is our heat measured in joules. The M is the mass measured in grams. C is the specific heat capacity, that number that we get from a chart that has 3 units. This one's going to be a long one to write, so hold with me. Heat, and then capacity, and that's where the C comes from. It's from the capacity. And specific means that every substance has a different heat capacity, or pretty close to different. They could be close to the same, but it's unique for each substance. So we can identify the substance by their heat capacity. And the units are joules over grams Celsius. So it's 3 units there, remember, on heat capacity. And delta T, that triangle stands for delta. This is the change in temperature. So how much the temperature goes up or down. And I'm just going to put the change in temp. And that's my dog playing with this toy down below and making it squeak. And it's measured in degrees Celsius. Okay, so I'm going to write the formula again and then figure out what I know from this question. So Q equals M times C times delta T. I'm going to try to see if I can type from here, because this one's not as hard. I'll type some of it, and then when I can't type, I'll switch. Okay, so let's look at the question actually first and what we know. So what are we looking for in this question? It says right here at the end, calculate the specific heat capacity of the iron. So that's what we're solving for. We need to solve for the specific heat capacity, and we know that is a C. So this is my goal. So I must have a Q, an M, and a delta T somewhere in that question. Okay, so let's look. So I see Q is right there. Let me change my color. Is 1,087.5 joules. That's my Q. Okay, so this is my Q. And then I see my mass is 15.75 grams. Okay, so that's my mass. And then I see my delta T is the change in temperature right there. The temperature changes from 25 degrees to 175 degrees. So there's my delta T. Okay, so now I'm going to put this into my formula. Okay, so my Q is 1,000. Let me change it to black. It's 1,086.75. Oops. 86.75 joules equals, and then the mass is 15.75 grams. And the C is what we're looking for, so that's my unknown, that's my variable. And then I see my temperature change from 25 degrees Celsius to 175 degrees Celsius. So we need to remember that that is my change in temperature from my final temperature to my initial temperature. Okay, so that's 150 degrees Celsius. So how did I get that? Okay, I'm going to do that down here. So my final temperature equals 175 degrees Celsius. My initial temperature equals 25 degrees Celsius. So I want to subtract those. When you subtract it, that gives you the change in temp. 150 degrees Celsius, and that's where that came from there. So you always subtract your final tincture minus your initial tincture, and that's where you'll get your change in tincture. Okay, so subtract those two, and that gives you your change in tincture. Okay, so I'm going to go back up here. Okay. Next thing I want to do is I want to multiply. So I want to multiply the 15.75 times the 150. Miss Cotta did not get her calculator ready this time. Oh, nope, I have it here. I just need to get some light on because it's solar. Okay, so 15.75 times 150 gives me 2,362.5. If I could speak, that would help. Okay, so I want to keep the 1,086.75 joules. And that equals 2,362.5. And then I multiply those two, so it's grams times Celsius. And I still have the small c. So all I did was multiply the 15.75 and the 150 and came up with this answer, and I still have c. Now, I want to solve for that c, so I need to divide both sides by the 2,362.5. So I'm going to do this one with handwriting now. Grams over Celsius. I'm going to divide this side by 2,362.5 grams Celsius. And I want to cross this out. Okay, so I'm just left with my c by itself because we always want to isolate. Okay, and then I'll divide it. So 1,860.75 divided by 2,362.5. Okay, gives me 0.46. And so I don't even have to worry about sig figures because my sig figures over here were 2, right? So I had 2 sig figures, two sig figures here, and I had 4 here and 6 here, but this only has 2. So my answer has to be with 2, but I already gave it to me. So it's 0.46, but don't forget about these units right here. These units matter, so it's 0.46 joules over grams Celsius. Now remember, this is a small c, that's a big C. So right there, there's your specific heat capacity of the metal, of this piece of iron, is 0.46 joules over grams Celsius. That's the specific heat capacity of the iron. Let's try another one. So let me go back, find the next problem. So how many joules of heat are needed to raise the temperature of 10 grams of aluminum from 22 degrees Celsius to 55 degrees Celsius if the specific heat of aluminum is 0.90 joules per gram Celsius? Okay, so first thing I need to do, I need to write my equation. So Q equals N times C times delta T. Okay. And let's look at my question. So I want to see what I'm looking for. So it says, how many joules of heat right here? So that's what I'm looking for. I'm looking for the joules of heat, and that corresponds with my Q. Q is my amount of heat in joules, so that's what I'm looking for. Okay. Then let's look for my other things. So I have 10 grams here. Okay. There's my mass. Yes, that's my mass. I have the C value right here. The specific heat of aluminum is 0.90, so there's my C. And my change of temperature is from 22 degrees Celsius to 55 degrees Celsius. So there is my delta T. Okay, so now I just want to plug these things into the formula. So I'm going to go back into typing again. Okay, so we're looking for Q, so there's my unknown. I'm going to change back to black, sorry. Okay, so Q equals, the mass is 10.0 grams. The C is 0.90 joules per gram Celsius. And the temperature change is 33 degrees Celsius. Now, how did I get that 33 degrees Celsius? Well, I remember take the final temperature. So the final temperature of the aluminum is 55 degrees Celsius. The initial temp was 22 degrees Celsius. I subtract those two and come up with a change. And that would be 33 degrees Celsius. Okay, so I just subtracted those two. So I subtracted my final from my initial. It's giving me 33 degrees. Now if I go back here to my formula, I see I can cross out some units. Let me cross this out before I do calculations. So I can cross out the grams, because I have grams and grams. And I have Celsius and Celsius, and those can cancel out because one's on top, one's on the bottom. So I'm left with joules, which is good because my answer needs to be in Q, right? It says how many joules. So my answer needs to be in joules. So I want to multiply these three together. So multiply this times this times this. And this one has 3 sig figures. This one only has 2 sig figures. And this one only has 2 sig figures. So my answer's got to be in 2 sig figures. So let me multiply all 3 of those together. So Q equals, and I multiply 10.0 times 0.90 times 33. And I get 297 joules. But my answer needs to be only in 2 significant figures. So if I look at my significant figures, okay, my first one was 2, and my second one is 9. And the number behind 9 is a 7. So that means I need to round up. And I have to round up drastically. So my final answer is 300 joules of heat. Okay, so because the behind the 9 was a 7, I round the 9 up. But since it's a 9, that makes the 3 round up. So 300 joules of heat was what was required to heat up this aluminum for 33 degrees. Okay? And that's the second problem. Let's go to the third problem. To what temperature will a 50.0 gram piece of glass raise if it absorbs 5,275 joules of heat and a specific heat capacity is 0.50 joules per gram Celsius, and the initial temperature of the glass is 20 degrees. Okay, so first things first, always write my formula. Okay, so Q equals M times C times delta T. Oops. Okay, and now I want to go, what is the question asked me to find? So what's my goal? My goal is to what temperature, right? That's the first thing it says. It says to what temperature will the 50 gram piece of glass be if it absorbs 5,275 joules of heat, and I have its heat capacity, and I have the initial temperature. But if you remember, there is no place for initial temperature in my formula. So this is just telling me what temperature the glass was to start. You want to figure out what temperature is it going to be now. Okay, so we got to figure out what temperature is it now. And so to do that, we need the delta T, because we know what the initial temperature is. We don't know what the final temperature is. In order to get the final temperature, we need to get the change in temperature. So we're going to look for this change in temperature. Okay, so let's look at what I do have. Okay, so I have 50 grams. Okay, I know grams is mass, so that's my mass of the glass. Okay, it absorbs 5,275 joules of energy, of heat, so that's my Q. So that's my Q. And its specific heat capacity is 0.50 joules per gram Celsius. And it tells me right there, its specific heat capacity. So that is its C. So now I'm going to go back to my equation. Okay, so I know, change it to black. So I have 5,275 joules of heat that's absorbed by this glass. And I know the glass has a mass of 50 grams. And I know its C is 0.50 joules per gram Celsius. And I don't know the delta T. Okay, that's what I'm looking for, is what is the delta T? What's the change in temperature for this glass? Okay. So next things first is I want to multiply. Okay, so I'm going to multiply these two together, okay, and figure out what that is. So now I'm going to work right below it. So nothing's going to happen to these joules, so I'm just going to keep that the same. So my joules stays the same. And then I want to multiply 50 times 0.5, and that's going to give me 25, but don't forget I have units, okay? I'm going to do something to these units because I see I have grams and I have grams. So I'm going to cancel those out. So now I just have joules over Celsius. I left my thing here, so I pick it up right here. If this works. Okay, so 25 joules over Celsius and still multiplied by delta T. Okay. All right, so I just multiplied these two together, the 50 grams times the 0.50 joules over grams Celsius, and I canceled the grams out. Okay, so now I want to isolate the delta T. I want to get the delta T by itself, so I need to divide both sides by the reciprocal. Okay, so watch what I do here. So I'm going to do it with handwriting because it's easier. Okay, so I'm going to flip this 25 joules Celsius. So C is going to be on top, and 25 joules is on the bottom. Okay, so I just flipped the sides. Okay, and then I'm going to multiply this side. I have to do it down here because I don't have room to put next to it. By 25 joules. Okay. These two will cancel out because I have the same thing on both sides. Okay. So now I'm left with delta T on the right, but I have this on the left. So I have joules and joules, so I can cancel those out. There's a joule on top, and that's a joule right there on the bottom. So I'm going to cancel out the 2 joules. Okay. Now I have 5,275 divided by 25. Okay, that is 211. And that has on top a Celsius. So 211 Celsius equals my change in temperature. So this glass is going to go up by 211 degrees. Okay, but first let me make sure I'm in the right sig figures. Okay, so let's go back and look at our original. So this one had 4 sig figures. So I'm going to make them notes. So I'll make them in yellow or orange. Okay, this one had 4 sig figures. This one had 3 sig figures. And this one only had 2 sig figures. So my answer needs to be in 2 sig figures. So that would be then 210 Celsius is my delta T. Okay, so I only want 2 sig figures, right? So here's my first sig figure. Here's my second. Okay, I want to round off behind the 1, and behind the 1 is a 1 again. So that 1 changes to a 0. So it rounds down and becomes 210 degrees Celsius. Okay, so this is the change in temperature. And read what is happening to this glass, what I just said. This glass is absorbing all this energy. Okay, and its temperature was 20 degrees. Right? So the initial temperature of the glass was 20 degrees Celsius. But the change in temperature, okay, is 210 degrees Celsius. Okay, and it's going up because it's absorbing this energy, right? So if something's going up, what do I got to do this math operation? I need to add them together. Okay? So if I add them together, that gives me 230 degrees Celsius. And that's what temperature the glass is now. Now that glass is at 230 degrees Celsius after it absorbs all of this energy. And that right there is your final answer. So 203 degrees Celsius is what the temperature your glass is now. Okay, let's skip the next question. Calculate the heat capacity of a piece of wood. So let me go back to black. Make a new box. Okay. Calculate the heat capacity of a piece of wood if 1,500 grams of the wood absorbs 6.75 times 10 to the fourth, and that should be exponent, but it's not because it doesn't change, so it should be a little exponent right there. Joules of heat, and its temperature changes from 32 degrees Celsius to 57 degrees Celsius. Okay, so let me write my equation. Q equals, so I'm going to type my equation. Q equals N times C times delta T. Keep doing that. Doing the wrong button. Okay, and now I want to look for what is the question asking me to find. Okay, it says right there, calculate the heat capacity. Boom, right there. So if I'm calculating the heat capacity, I know the heat capacity is C. Okay, so there's my heat capacity. And then I want to see what else it's giving me that I can put into my equation. So right here I have the wood is 1,500 grams. Okay, so that is my mass of this piece of wood. And then I have it's absorbing 6.75 joules of heat. Okay, so that's got to be my Q because heat's always Q, joules is always the Q. And then I have my change in temperature. So the wood was 32 degrees and now it's 57 degrees. So that is my delta T. So I'm looking for this C for this piece of wood. Okay, so I know the Q is 6.75 times 10 to the power 4 joules. And I'm going to change the joule to capital J. Equals, and I know my mass is 1,500.0 grams. And I'm looking for C, so I'm just going to keep it C. And then I have my delta T, and that is 25 degrees Celsius. Okay, and that wasn't on there, but remember what we have to do. So let's do the math on the side. So we want to take the final temp, which is 57 degrees. I always need to put a period after the equal sign like that, and I have no idea why, so just ignore it. It's just some glitch in the system. And the initial temperature of the wood was 32 degrees Celsius, so I want to subtract those to find the change in temp. Okay, I'm going to subtract those two. That's very ugly. This one is subtract the 57 minus the 32, and that's going to give us 25 degrees Celsius. So that's where I came up with that 25 degrees Celsius in the equation. Okay. So now we want to do some multiplication. So we want to multiply the 1,500 grams times the 25C. This 6.75 times 10 to the power 4 joules is going to stay the same. And then I want to multiply the 1,500 times the 25. And that's going to give me a big number, 37,500. And I got to multiply those two units, the grams times the Celsius. And we still have the small c. So all I did was just multiply these two numbers together. So I multiplied the 1,500 times the 25 so I can start getting that c by itself. Okay. And so in order to get c by itself, I need to divide both sides by that 37,500. So 37,500 in grams Celsius, divide on the right. Do the same on this side. So 37,500 grams Celsius on the left. And this will cancel out now on the right. So I just have C by itself, small c. Now 6.75 times 10 to the 4th. Okay, so I want to change it. I'm going to change it to a normal number from a scientific notation. So I take the 6.75 and I have a power of 4, and it's a positive 4, so that means my number is going to get bigger. So I'm going to get money. 1, 2, 3, 4 spaces. Okay, and I have 2 empty spaces, so I want to add zeros there. Wasn't the prettiest, but there you go. And that's in joules. Okay, so I'm going to type that down here. Type it out. So I have 67,500 joules equals C, but this part is over 37,500 grams by Celsius. Okay, and then there's a line between them. There's that fraction line right here. Okay, so I have just changed this into a regular number, and then I'm just going to divide them. So 67,500 joules divided by 37,500 grams Celsius. So I just want to divide those two. So 67,500 divided by 37,500, and that gives me 1.8. So 1.8, and I need to keep, and I don't have to worry about significant digits again because I only have 2 significant digits. And if I go back up here and look at my numbers, this one had 3 sig figs right here because the 6.75 has 3. This one has 5 significant figures, but this one only has 2. So 2 is my lowest, and my answer has 2, so it's perfect. So my answer is 1.8, but don't forget about those units. Joules over grams Celsius. And that equals my specific heat. So that's specific heat of the wood is 1.8 joules per gram Celsius. So you can see the wood doesn't have as high heat capacity as water. Water's heat capacity, remember, is 4.18, so water's is higher. But remember that question when I asked you, what would you want to sit on if Miss Cotta was doing a lecture outside in the 100-degree weather for an hour? Do you want to sit on a metal chair, a plastic chair, or a wood chair? Well, definitely not the metal, because we just did iron, and iron is 0.45 joules per gram Celsius heat capacity, so it's really low. Whereas wood is higher, 1.8, so it's 4 times higher heat capacity, so that wood's going to heat up 4 times slower than that wood will. But if that plastic chair was hollow and we filled it with water, then that would be the coolest of all, because water has a low heat capacity. So if you had inflatable furniture that you could fill up with water instead of air, that would be the coolest temperature of all of them, right? If you had a water. And that's why if you had, like, they used to have water beds, they had beds filled with water, or they have beds now filled with the gel that has a high heat capacity. Those feel cooler to you because they change temperature slower. That's what's happening in those. If you have a bed that has a Miracle Gel in it, or a pillow that has Miracle Gel, they feel cooler because that gel has a higher heat capacity than the fabric around it. So it feels cooler to the touch. Okay. So there's part 4. I'm going to stop the video here, and then I'll make a second video tomorrow. Okay. So hope you learned something, and if you have questions, send me an email.